So, hi everyone, I'm Yannick. It's very nice to meet you. It's going to be my very first talk. And as I found out today, I am a little terrified of public speaking. So just like with dogs, it's okay. I'm more scared of you than you are of me. And then another thing why I really wanted to have a double screen setup is because I reshuffled my slides, and so I might just lose track of where it is where, but it's okay. We're going to get through it together. So, as Philip briefed you on it, there is a lot to technical debt, and we also had, thankfully, closer to past tense than present, a lot of it. And so it's difficult to discuss any particular thing, or rather the big picture item, and condense it into half an hour. So what I have specifically done is I have selected one particular horror story from my experience with dealing with technical debt. And that is something that I'm going to tell you in form specifically of a story. So I'd like you to turn your imagination for just a second with me and imagine that you're a young sailor, seaworthy, proven, but still very ambitious, and you've just been placed as the helmsman of HMS Frontend, a schooner in Her Majesty's service of specifically the whaling fleet. And you've just been approached by the admiral to go hunt for your very first whale. Before we get into the very confusing bits about this metaphor, that is specifically just a very large feature that we have in our application. The admiral could be literally anyone, but let's say for the sake of argument, it's a handsome devil named Philip. So, you set out hunting, and you hear the rumblings of a whale among the sailors, gossips of particular sightings. Perhaps it was a fair bit of jQuery located in just one method in the entire application, nowhere else. Or some functions which take any as a parameter and of course return any as well, because why not? There was specifically something that I wanted to show you here as well. It was an outcropping which was very difficult to get as a screenshot to show during a presentation, but imagine a function with nested switch cases that is running on every single render cycle. That is the level of code that we're talking about. So here she is. That is our white whale. She is a large page that has many children and very high levels of complexity. She's 10 plus years old, specifically because she's the core value proposition of the product. So it has a massive user base. This is specifically the reason why people pay us money. High risk. We're talking about over 1,700 lines of code split between the component and an abstract class that it extends. You might then surmise that we clearly have a division between the view state and the view logic where it lives in the component and the model that lives in our abstract class. Nothing could be further from the truth. All of it is just randomly placed wherever. Then she has a little bit of a hankering for Italian food because she is chock full of spaghetti. As an example, for instance, the primary function that she has is 167 lines of code. Maximum nesting depth of 8, but she does maintain a steady 6 most of the time. High cyclomatic and cognitive complexity, of course, because how else? DOM manipulation, I'm so glad that you asked. It's there. And comments, any form of documentation, they're here, but they are explicitly in German. Wait a second, I have a strong feeling that this is about my battery settings right now. Yeah, that seems right. Okay, so we met our whale. Which means that this is the perfect time to start mixing metaphors, is it not? Who doesn't like a little bit of confusion? Are you familiar with this picture? For anyone who remembers from Grundschule, from grade school, this is a picture from The Little Prince, and it is not a picture of a hat. It's the picture of a snake eating an elephant. In our case, let's imagine that it's a whale. So as we can see already, the snake has made one very crucial mistake, is that it's eating the entire thing in one go. We can't judge the snake very much. It's not a very good engineer because you see it doesn't have opposable thumbs. But we are, I would hope, good engineers. And so we know that we really shouldn't be eating our whale in one go. We should be cutting it up into pieces. And so the very first step that I would say in handling, and at this point in time, I'm actually going to drop the metaphor a little bit because it's just going to get confusing. The first thing in handling large code base with a large amount of technical debt, I would say, is specifically the fact that this is a team sport, much like whale hunting, and you're not going to be doing this alone. And so we should really start by defining our team tactics. Coding guidelines, testing guidelines, this is, remember this sentence, we're going to come back to it relatively soon, and the way that we are structuring our workflow. And don't worry, also, we are going to go a little bit deeper into those points as well. This I'm going to skim over because I don't want to get a little bit, to get overly philosophical. But something that I'm pushing for very hard, and my junior is sitting over here, and I'm pretty sure that he knows that I'm being a little anal with pull requests when it comes specifically to enforcing these values. But it's simplicity, legibility, uniformity, readability, and predictability. Effectively, the things that I value the most in clean code. You might think legibility is a little bit redundant because it's implied by everything else, and you would be correct. I just really wanted it to say slurp. The idea behind it is basically to keep the cognitive load to a minimum and let yourself parse every piece of code that you encounter with ease so that you really don't have to think, you just see and you know. So, now that we have established our ground rules, let's take a look at our prey, our imperative monolith. First thing that we're going to do, same as with everything else, is we're of course going to take a look at the code that we're working with. But importantly, I would argue, so as I set out in the description of the talk, this is going to be about the do's and the don'ts, and I'm going to be predominantly talking about the do's, but rest assured, for every single rule that I'm talking about, the more I argue for it, the more I can tell you I have broken it and it came to bite me back in the ass. So the thing that I would start out with is really analyzing the code in a relatively simple fashion. Effectively kind of just skimming through it, getting a relatively good idea of, hey, what is this entire big picture thing, but not going too depth into it. Why? Because the next thing that if I could go back in time and fix my own choices, what I would go and look for is someone who is very well versed with the functionality. So when we're talking about a 10-year-old monolith, there's going to be usually some tribal knowledge that is lost in time. We're not going to have actual documentation to work with. That is, at least has been my experience. But we do have something else. And that is frequently people, often non-technical people that live or that work in our company that can help us out a lot. And usually if you're working in a specifically software-centered company, that's going to be your product owner. But for instance, in our case, there would frequently be people working in sales, people who show the functionality on a daily basis to our clients. Why are we going to be doing that? Number one, of course, we want to educate ourselves on the business logic that we are working with, understand the functionality. And the next step would be to document it. But before anyone gets their pitchforks, I'm not talking about uploading technical documentation to Confluence. Of course not. I'm talking about creating an interim documentation that effectively kind of just lets us define our test cases. And here's the sentence coming back. Given condition A, when condition B, then outcome. This is something that we have defined in our test cases and what we have arrived on in our push to integrate more and more testing into the software, increasing the testing coverage, which has been a massive change in the amount of quality assurance that we can do on an automatized basis, is that AI specifically, and of course I have to name drop it at some point, is really, really good at writing unit tests. Things that are boilerplate and really annoying for us to write, but it gets away with doing it exceptionally fast. But the one thing that it struggles with is knowing what exactly to test. And that's what we're doing right now. We're just defining a list of sentences, really simple ones. Hey, when, for instance, this scenario has been loaded and this user clicks on a particular button, then we expect a particular outcome in it. And the AI is really, really good at writing those test cases for us then. Now, before we get into specifics of the testing and why I really, really push for it before we start any form of refactoring, a quick sidebar on API and component API structure. This is how we defined it in our coding guidelines and how I like to think about it. I mean, private, of course, is very self-explanatory, right? It's just the component internals. Public, equally self-explanatory, is the members of the class that are exposed for architectural components, so components and services to use programmatically outside of the component that we live in. But the thing that I found very interesting is we have agreed on using protected specifically as an access modifier for everything that is getting called specifically and only from, or at the very least from, our templates. And that helps us massively when reading the code and trying to parse everything, which is specifically, it is suggestive of user interaction. Why is that important for us right now? Well, because we're going to be doing our testing. And what I would like to focus on in the testing is exactly the things that we have gotten as information from our business logic expert. And that is the way that the users interact with this logic, right? And so that means, yeah, we started with our documented functional requirements. We have defined test cases for our should be actually protected API, but of course public is going to be included as well. Why are we going to limit ourselves to this? Number one, there's a lot of code to test. And we are not going to be sitting there for weeks and weeks writing all the test cases. We want it to be specifically localized to the things that really matter for us. And then we're going to be testing exactly the user interaction. So things that are the most important for our value proposition and the things that we found out the most information on. And of course, keep it simple, stupid, we're on the clock. And like I said before, we have done the human part, the AI can do the busy boilerplate work for us. Now, at this point in time, we are familiar with our business logic, we have our testing setup, which means that we can now get to the actual meat and potatoes, the refactoring, the fun bit. But I wouldn't start with anything large just yet. The one thing that I would definitely start taking a look at first, and this is even something that you could do before you start running your test cases to really get a better view of what is protected on public API, is specifically refactoring just the low-hanging fruit, the minimum risk, things that we are certain we're not going to fuck up anything when we touch. And so, if we have something like this cryptic method where, oh, it takes 2 arguments, but we have no idea what kind of a return type is, we don't actually even know what the arguments are, we have no idea what the access modifier is, what do we have to do? We have to read the goddamn code that lives inside of it, which is no bueno, because then we have to put our mental energy, the cognitive load, into actually understanding something, and there is a limited amount of energy and intelligence in this skull. And so I would like to not have to do that. Now, not sacrificing a goat to the linter plays into the obsession part of the Moby Dick metaphor that I'm talking about. I don't know about you, but I feel like linters really gamify refactoring for me, and I love to see how the lint is running away. That is tempting you to make functional changes. Don't do that. Do only low risk at this point. Here is something that I would like to see at this stage of refactoring. This is a method signature that tells me exactly everything I need to know without having to read the code. I see that it's protected, which means that it's maybe used privately and from the internals, but it's definitely going to be using from the template. I have a pretty good naming convention. For instance, I really like to see that there are verbs in the naming convention of methods because they are indicative of behavior. We have our arguments, which are typed, and we have our return type as well. And better yet, this is something that I find absolutely astonishing nowadays, is that when you just click, put your cursor over here, and then see Copilot just write this entire fucking block for you, and all you have to do is press tab and then maybe do a little bit of editorializing because it's a little bit too verbose in writing this documentation. But then, at this point, you really don't need to read what is happening in here unless you specifically, well, need to get into the nitty-gritty of the behavior. But when your eyes are just scanning over the code, you instantly know what is where and why. So, when we're doing this kind of refactoring, I told you at the very beginning, just do the minimum analysis. Really get to the next part as fast as possible. This is the moment where I would say going really deep and actually take a look at what is the blast radius. In our case, it's going to be the entire page, so we know for sure that basically every single child is a downstream dependency, quote unquote, that is going to be affected by what we're doing. And identify what is the model and what is the view state. This is also something that we're going to circle back to a little bit further. And then, just as we did before, document your findings as method documentation and comments. You can get very verbose in this situation because the idea is anyways to do that refactoring. We're going to be rewriting the code so that we don't need those noisy comments, but right now they are actually helpful for us. And then keep an eye out for redundancy, especially right now in behavior, but do not get tempted to introduce abstraction at this point. I've done that many times. Every single time, I might as well just have shot myself in the foot. So, checkpoint time. What have we gotten to thus far? Well, we have educated ourselves on functionality, right? We have defined our test cases, which means that now we have test coverage on the problematic part of the code that we are working for. We have performed refactoring to make it look just a little bit more presentable and readable. And we have done our analysis where we have actually done the estimation of, hey, how risky is this going to be to work with? So what do we do now? Ideas? Honestly, usually at this point in time, I would say, leave it fucking be. Seriously, don't attack it any further because at this point in time, you have expended your time as a developer, and your time is an expensive resource. I don't know if you guys checked lately, but more likely than not, probably all of us developers here in the room, we're in the top 20% of earners in Austria. Our time is really goddamn expensive. Then scope and requirements change over time because we have been treating this as though we were living in a vacuum up until right now, but that is really not the case because you have other things to work on, other features, things that you need to implement in order to sell more units to your clients, right? And you have to be, and I hate saying this because I always was annoyed reading the Agile Manifesto as a student, but you also have to be able to react to those changing conditions with agility, right? And last but not least, you might have failed the bus test, but your code really shouldn't. So if you want to be morbid, if you get ridden over by a bus, but if you want to be a little bit less morbid, you have a nice holiday. Someone should be able to be in a situation where can they really just pick up from where you left off, right? We don't want to be indispensable, as it were. But let's say that we have gone through all of this and we have arrived at the point where, you know what, fudge it, we're going to attack it anyways. In my humble opinion, the bit that I have found always to be the most difficult and complex part wasn't the behavior itself, but rather the state and how we represent it. I watched a video essay relatively recently, probably also by a YouTuber that you guys are familiar with, and he had a very interesting metaphor specifically about Picasso's bowl. He made the series of drawings where he was reducing the bowl bit by bit into what is the most essential thing that our brains still recognize as being a picture of a bull. And I think that this is a very, very apt metaphor. We want to keep our state to an absolute minimum, to make it extremely self-explanatory. And generally speaking, if we do all of these mental exercises to get to this point, we're also going to have a significantly better mental model of not only the state, but also the logic that interacts with it. And aside from that, model, of course, should be our only source of truth. In the process of getting to this, getting to the most minimum representation of state that we can work with, I would say don't rely on your instincts. At the very least, they have failed me. I don't know, maybe some older, more experienced developers can rely on them more. But what I have found is, I'll jump back again to AI, my apologies, is not necessarily to just say, give me the most minified version of this state possible, because again, this is a little bit complex for AI to work with. But rather, be my Socratic rubber ducky. Ask me questions, try to suggest what might be issues, what are the trade-offs or SWOT analyses of my ideas, help me think for myself, rather than give me the final output on a platter. Now, addressing this specifically, I'm sure that this is going to invite some amount of debate. My personal favorite weapon of choice is the NGRX signal store. Is it the optimal way of dealing with state management? No, it's just what I like. Like, I understand that there's reducer pattern-based solutions. There's a lot of other options that people were like working with. This is just the thing that I like working with, and I can tell you more or less kind of why, right? So, especially when thinking about the monolith that I'm talking to you guys about, what happened quite a bit is that we would have state living inside of our main component, and then we would just be pushing it as though with a wheelbarrow downstream to all the children, and then expecting children to be reading interactions with the users, like just simple event bindings. And so we would basically just have a situation where the state is being pushed down through, as though prop drilling in React, and then we would be bubbling all of those events through event emitters back to the parent from the innermost child, the one where the event was being read. I like to call it IO drilling. I have no idea if that is the actual term. But this, of course, like as every single state management solution, solves that issue for us, because we are talking to a separate entity that doesn't live inside of the flow of our tree. It enforces a particular structure. So I don't know if you guys read Uncle Bob's Clean Architecture, but there is a chapter where he's discussing specifically the go-to statements or jump-to statements. I don't remember exactly, that was before my time. But the one very interesting take that he had about them is that introducing limitations, taking away some of the freedom that we have, is actually really good for us. Because, well, yeah, working with a structure can substantiate it better. It's just structured, right? We want our work to be structured. What I like specifically, though, about Signal Store, and the previous point is a little bit closer to why I like it. I like working with it better than just having a service that does it for us, because services are pretty free-form, is that everything inside of or most everything inside of a Signal Store is just going to be a signal. So we can really just go absolutely, well, I'm not going to say the thing, but neck deep into working with signals and relying to have our mental model to be specifically signals. And another thing that I'm going to show are structural regions. So the anatomy of a signal store is we have our core imperative state, right? This is usually where we're going to be putting our model, or at the very least, let's say if we have our harpoon store where we're going to be setting up for our whale hunt, then probably when we're navigating to that page, we're going to be reading the whale ID from the URL and then passing it. Let's imagine that there's an initiation function. We're going to be setting it, and then I already know what to do with it. I have a resource that is going to fetch this particular whale for me using the whale ID. Then we have our props region. This is service injections. I like to put forms. I like to put effects in it as well, which I know is a little bit debatable, but still. And for instance, resources, things that don't really necessarily neatly fit anywhere else in the signal store. Then of course we have our with methods, which is where the behavior lives in a really self-explanatory way, and with hooks, where we have access to, I believe, only 2 lifecycle hooks, on init and on destroy. The neat part about it is, the thing that I definitely like about it more than Redux-based solutions, is that everything that I receive from it is going to be signal by default. Then, another API sidebar, as I was talking about how we like to structure our API, I think that this is another kind of neat feature of it, is that you're not going to have, that you can structurally enforce which part of the API is public and which part of the API is private, not necessarily, sadly, through keywords, right? But number one is that you can use this indicator similar to the native private indicator from JavaScript, the hashtag, and this means that the signal store is going to immediately know, hey, this is a private method. I'm not going to be showing this to any of my consumers. But what else you can do is, well, this is just a callback, right? And so whatever we want to return from it has to be returned from the block. So if we have our private method and we don't want to expose it to our consumers, we just don't put it in the block. Press stop, and that's it. Also, yeah, harkening back to the testing discussion, very much recommend doing basically the same thing with the signal store as with our components. Just have even an AI-generated unit test file where all you tell it is like, hey, look, I have my unit testing guidelines already set up in this repository. I have the list of my public API, and you can structurally tell what it is. Just make sure that those are tested. And of course, review the code yourself afterwards, right? Good. Then this might be a little bit reductive, but who doesn't love a reductive hyperbole? I assume that everyone here, as a passionate Angular developer, is relatively familiar with signals, right? No? No? Just a show of hands of someone who feels very comfortable with signals. Okay, great. Cool. So, again, a little bit more high concept and philosophical, but when we're working with older Angular code, imperative Angular code, quasi-imperative, we're thinking about a set of instructions, right? We're giving it instruction to go specifically set step by step, hey, this is happening here, and so therefore update this piece of state just because I told you to in this line by line set of instructions. When we're thinking about this more declarative approach, what we should be instead thinking about is that we are not really giving it instructions. We're giving it a set of rules to follow, declaring a set of rules for it to follow. And so derivative state, which is usually going to be, for instance, our view state, right? Whether we want to show a loader or not. This is going to be effectively just, hey, I am giving you a rule wherein, right, this is a function of my core state. The dependencies in this case are the is loading signals that live within our resources. And so whenever our whale resource is loading or our weather resource is loading, we're going to recompute is loading. You never have to keep track of it yourself. You basically just tell it, hey, this is the rule. Whenever we're looking for our whale or our weather, we just want to show the is loading bar. Now, That's the computed, and the computed you cannot set with a setter. Then there is a slightly different flavor for derivative state, which is quite neat, and that is linked state. What linked state does is effectively it gives us two options to work with itself. We give it a callback for a computation, and whenever it recognizes that, hey, there is a signal in here, I should probably recompute whenever that is the case, whenever the value of it changes. But we also have a slightly different option, which is to just use a setter on it. So if we, for instance, have a harpoon that is preferred for a certain type of whale, thank you very, very much. So if we have a harpoon that is preferred for a certain type of whale, number one, let's see. So we have whales that potentially hold a preferred harpoon for it, if we know which harpoon is preferred for hunting it. Then we can default to the usual type of harpoon, the one that we use most often, barbed. That was a fun Google search, by the way. But then at any point in time, we could say, for instance, that we want the user to be able to choose their weapon if they'd like. And so with that, all we have to do is actually just call the setter on the harpoon signal, and we can just update that. What's going to happen, though, is that if at any point in time we're going to change the whale, like as we had before changing the ID and our resource refetching a new whale, it's then going to trigger this callback again and check, hey, do I have a preferred harpoon? If so, then use this one, and if not, then default to the barbed. Yeah, for dealing with the computations, there is a very, very neat trick that an older colleague of mine has showed me that I'm absolutely in love with, which is kind of just pulling in a little bit more of functional programming into the mix, which is dealing with pure functions. So in this instance, let's say we have a slightly more nuanced choice of our harpoon, and there's going to be a little bit more logic. Well, we just discussed that one of our core values with this is readability and simplicity. And so it would be a little bit annoying if we had to put a larger function in here. Rest assured, there is a much better way to do it. And that is to kick the function that does the computation, completely out of the context of our store. This can be done, by the way, with basically any signal, everything that I'm talking about, right? For improved structure, I like to put these even in util functions to basically limit just the amount of lines that we have in our stores. But effectively, what we're doing right now is that because this does not exist within the context of the store, that means that it cannot possibly physically have any side effects. It cannot interact with something that it's not meant to interact with. And secondly, given the same input, it's always going to have the same output. The two criteria that make it a pure function. But it's not all sunshine and rainbows. There's issues with it. There's always issues with things. Number one is you can do the same thing as you do with all other types of signals. You can overuse effects. You can just say, hey, I have a signal and I would like to do some mutations on it. So how about I put those mutations in an effect? Whenever something changes, I want this signal's value to be updated. Congratulations, you have now reinvented imperative programming. Then linked state also has a particular issue, one that I'm sure you as very, very astute observers have noticed before, right? What happens if I'm setting something and might be a reference here to something that is set via an API call that would basically make it potentially vulnerable to a race condition if there is an async interaction to it. And in fact it is, and I can tell you this is really fucking annoying to debug. Then, generally speaking, what I found when I started preparing or declaring declarative signal stores, yes, great usage of words, is that it makes it a lot easier for us to create significantly more state. Because we don't really have to juggle the mental gymnastics of keeping track of that state imperatively ourselves. We're just telling it, hey, whenever there's something, whenever one of the dependencies change, just give me something new. And then before you notice what's going on, you have your API model. Then you process the data and you have a normalized model. Then you flatten the state because somewhere you need to use those members of the object, maybe as a collection. Then you're going to localize it into other components. Then let's say the consumer A consumer A being, let's say, component A, has its own view state, it has its own wrapper, we're going to build it, it's really easy for us to do. Why not create a separate piece of state for it? And then consumer B needs a slightly different wrapper with slightly different pieces of state, but all of that is going to be computed from the same thing, because it's fine, it's okay. And then before you realize, you're building yourself another white whale because you weren't listening to Picasso. Yeah. Then back to these, the done with coding, back to the high concept things. Sailing with accountability. This is something that I would say, especially the more senior we become, the easier it is to deal with the complexities of code. And for me, at the very least, frequently the issue when working with these large-scale reworks and handling very intricate and difficult technical debt wasn't even the fact that, hey, I have no idea how to code this. It's the reason why I chose Moby Dick as the main metaphor and reference is because you just get obsessed. You start seeing this as a personal challenge, something that goes against your pride, and you need to finish it, and you start putting in overtime. But then at the end of the day, somebody just taps you on the shoulder and goes like, how about the other tasks that you had to work on? Maybe those should be prioritized as well. And you realize that you are now well and truly fucked because you have a 6,000 line pull request that is not really finished, but you really have to start working on something else. And so frequent pull requests every single time. As soon as we get to a point where this can be merged into an epic branch, we do it, and we do it without a second's delay. So if we would go through again the steps that we had taken before. That would be us documenting the functional requirements as test cases. Maybe for that one, if we're doing it with the AI, we can basically say like, hey, look, this is my description. I want you to do that. Then it generates it. We review it ourselves. We check the code coverage locally. By the way, for that, I recommend using ng test running the entire time in headless mode to just constantly have the information and reports on the regression that you are inevitably introducing into your code base. That is a pull request. The low-hanging fruit refactoring, that is a pull request. If there is any way that you can cut up a section of the task that you are working on and separate it into a separate ticket, into a separate pull request, do it for the love of God, for the love of yourself, and just for the love of going home early. Then another thing is, as annoying as it seems, you do want to have oversight. You want to report to the people who get to decide which tasks go into the sprint, because you want to keep good rapport with them, because again, this is something that is like, your time is expensive. You're an expensive resource. And they need to be able to plan around how far you're getting along with this. And the more honest you are with them about it, the better. Come on. Okay. Yeah, and dividing work into sprints, basically kind of just like a slightly more high-level version of what I was talking about. Keep yourself honest, including to yourself. If this right now needs to be put on the back burner and you need to focus on something else, put your pride back in your pocket. It's okay, you've already done a lot of great work. Just do something else. Also, give yourself the moment of a small win, of a bug fix every now and again or something, just to clean your palette. Yeah, going back to the metaphor, don't let your obsession jeopardize the safety of your crew. Yeah, so that is us basically coming to an end. As a short summary of what we've learned today, I don't know, maybe, hopefully. Familiarize yourself with the business logic. Really understand what it is you're dealing with. You're not going to be able to test it, like smoke test it or manual test it very well yourself. At least I don't. Maybe it's just because I'm not great with testing. But automatize that and internalize what you know about it, and then you can also just externalize it into documentation that lives inside of the code until the code is written clean enough that it is self-evident. Analyze the impact. Be honest with yourself about how big of a risk and how big of an undertaking it is to try this rework. Start with low-risk refactoring. Just make it as clean as you can without touching the functionality in any way whatsoever. Continuously test against regression, continuously. Best case scenario, of course, if it is integrated in the pipeline. But what I found to be very useful as well is that I genuinely just run the test cases, the testing suite locally on my machine, and just like a headless mode so that Chromium doesn't eat all the possible resources, because we are living in a RAM recession, but still. But get constant feedback on what are the things that you're fucking up, because you are inevitably fucking up something. And it's the classic case of like, ooh, my dinner table is wobbly. Let me put a book in underneath there. And then you turn around and the fridge is on fire. Exactly the case. Divide and conquer. Divide your plan into small, self-contained, logical steps. Try to be your own PO, or genuinely do ask PO for help to build smaller tasks that are easier to digest and let you pull requests more frequently. Yeah, that one. And yes, that one. Work agile and enforce accountability in yourself. Minify state, like with Picasso's bowl. And this is something that I had wanted to include in the talk. There's some cut content, shall we say. But yeah, one of the things that I would definitely recommend is if you see redundancy, don't rush into an abstraction. I know that it's exciting, like this is the things that we really live for, is designing some cool solutions. But sit with the redundancy, look at it, get comfortable with it, lick it if you have to, but don't try to solve it first things first. Really let it exist, and then when other things are really well wired and you're looking at it and it seems to you that you found a mess of cables and you left it everything in beautiful cable management, that is the time to introduce fancy abstraction. That is the time when you treat yourself with a cherry on top. And then you turn on TypeScript strict mode and everything goes to shit anyways. Okay, that's the end.
Thank you, Jan, for that great talk. Do you guys have any questions?
Thank you very much for the vivid talk. I really enjoyed the metaphors and the storytelling. Could you maybe elaborate more on the motivation of the refactoring, or like what were the specific challenges? Why was it necessary? What was the state before, and what was the goal? What was the main objective for the refactoring?
Do you want the honest answer?
Yes, please.
I'm a masochist. Like there really wasn't that big of a functional reason. There was basically like, maybe I could go and look in the slides. There was in a bit of the content. I did a slide on Powerpuff Girls. I was really excited about that one, but I couldn't really include it. Basically, the explanation is that we have this feature not just once, but 3 times. And all of it is completely redundant, like they share no logic in the sense that they are based on the same logic, but it's just copy-pasted, right? And I wanted, like, I could see in my future at some point in time, the moment when I get approached and they're telling me, like, you have to modify this, you have to extend it with an initial functionality. And at that point, the best I'm gonna say is like, ciao, I'm out. And so I wanted to get ahead of that. And another thing was just kind of like, it seemed like a cool thing to do.
Okay, so main goal was maybe unification of 3 different code blocks or like functions.
Mm-hmm. Yeah, yeah.
Okay. Thanks.
Does that answer your question?
Yeah, I mean, I don't deserve a Raffle ticket for this. It's all good. Thank you.
Anyone else? There you go.
Hey, thanks. First of all, I would really like to appreciate you mentioned that this thing can become an obsession. I think I'm in the same situation in my project that's been running for 8+ years. And my question is kind of follow up on a previous question. How did you convince management and your POs that they should spend the money on this? Because that's what I'm struggling with the most.
Yeah. So at the very beginning, I didn't. I just started working on it whenever I had the time. And it turned out not to be a good idea. Would you look at that? But then eventually, I mean, it kind of just comes down to the work culture that you have, a little bit to the reputation that you have as a developer, right? A little bit to the management structure. Like I would say there's a lot of things going on. But one of the things that, it wasn't specifically connected to this, but I would say, and this isn't like me glazing the company, we are blessed with people who are in management who actually like do care and do think. And so when I approached one of our C-level higher-ups at some point in time regarding something different, but it was a similar case where I wanted to get ahead of the potential issues that I could see already happening up front and just tell them, look, like, long term, we would be saving on maintenance doing this. We would be, because like, as it is, if you're just being honest, especially if this is not code that you've written yourself, and you're not going to be throwing yourself under the bus, you can just go like, it's shit, and we really can't maintain it very well. And so this is the best way, if there is any planned modifications or extensions to this feature, this is the best way for us to get ahead of just massive potential issues in the future.
Next question.
Thanks for your talk. I really appreciate it. I'm in a very similar situation right now, like rewriting code, Angular code written by Java developers, which is another story. And I just wanted to ask you, would you recommend NGRX? Because we don't have it, we don't work with it. Why NGRX? A few more words about that.
So there's a couple of flavors of NGRX. There is like I think it's a reducer-based, please correct me if I'm wrong, but a reducer-based implementation of NGRX. And my limited research with it was basically like the same issue as with all reducer pattern-based state management solutions, which is just boilerplate upon boilerplate upon boilerplate. That's why we chose Signal Store, also because like we had like a massive internal push for signals. We like me and the other senior were just super duper excited about them. We wanted them in our code base as much as possible. Yeah, yeah, exactly. Yeah, but I mean, I haven't worked with other state management libraries in Angular specifically, but I remember reducer-based ones from a React past, and I wasn't a huge fan of them. This one, I have to admit, I'm actually very happy with.
Okay. Was it difficult to learn it, to implement it?
It's thinking in signals. So if you can think in signals, you're good, basically. It has some of its own complexity, sure, but it's kind of just like, you know, like with Tailwind, if you know CSS, you kind of know Tailwind, you just have to get used to the idiosyncrasies. Yeah.
Any more questions? Here you go.
Seems that you have like you used a lot of help of AI, and if you think about doing it without AI, would be possible, and like how much help, because analyzing of the logics and writing tests.
Come again, sorry, could you speak up a little bit because I can't hear you much.
It's just okay, so I mean like it looks like without AI it would be very hard to do the refactor without help of AI, without this testing, writing automatic tests, understanding the logics, writing comments. So would you do it without help of AI? Because I did it some of times. It's like I'm not sure it's worth it.
I've done it without AI, but I've done it without AI also before I became senior. and I just didn't know any better. That is already like a big part of the answer. Nowadays, likely, probably not. Not really. One of the things, because like the reason, one of the biggest reasons for me personally why would be just specifically the regression. Because you're just, I don't remember, there's a game like the mole hunt where you just like, you kill one and there's another one popping up. It's like that constantly. And the amount of work that you would have to put into writing all of those unit cases yourself, or other than like you just define the descriptions of the test cases, you press a button and they're there. It's a massive workload. And so, yeah, I would probably tend towards nah. Yeah.
Thank you. Anyone else?
You said something about don't follow your intuition, experiment. I do it the other way around, or I feel it the other way around it, about it. You experiment and do prototyping to build an intuition, to be able to implement it in an ordered way afterwards. And my question would be, because you talked a lot about the documentation at the first step and just code structure at the beginning, how much is prototyping part of this? Not necessarily in product, but you take some specific page, dashboard, whatever, and prototype independently from the whole shebang that you have around it usually.
That is a very good point. If I could go back in time and rewrite this presentation, I would include it. So number one, yeah, I think that you also formulated the idea behind the relationship between experimentation and intuition a lot better than I did. Admittedly, this was also something that was one of the mistakes that I didn't do, is that I didn't prototype enough, just like from the outside. If I were to start it again, I would probably go for 3 prototypes where I get to, as fast as possible, to like medium level of complexity, then have a discussion with one of our like backend architects who's just like a very smart dude, and try to together kind of just choose the best one based on the trade-offs. Does that answer your question?
Do you have more questions? No? Then big applause for Jan.